Today we're going to look at two parts. So there are two parts to this lesson. The first is called independent events. So please write this heading down and these two sentences in blue. So independent events are two events or two things that are totally separate from each other. An example of this is I've got a die in my left hand and a coin in my right hand. They are two separate events. If I flip the coin, whatever that lands on has no effect on what number the die will land on. They're two totally separate things, and that's what makes them independent events. If I roll the die and get a 4, that has no influence on whether the coin will land on heads or tails. So because they're totally separate from each other, that makes them independent events, and that's what we're going to look at today. Start with this example. Remember in primary school when you had to choose a class leader and someone got to be the leader and they got to do really important jobs like take letters to the office or help you pack up at the end of the day, whatever. We're at grade 2 and we're at grade 3 and each of them need to find a class leader. Here's the information that you need. There are 22 students in the grade 2 class and the teacher's going to randomly pick a name out of the hat. And there are 17 students in the grade 3 class, and their teacher's also going to randomly pick a name out of the hat to see who the class leaders are. Adam really wants to be the grade 2 class leader. And Sophia, she really wants to be the grade 3 class leader. Tell me, what's the probability of the teacher picking Adam's name out of the hat for the grade 2 class leader, and what's the probability of grade 3 teacher picking out Sophia's name? Pause and write down that information. Write down your answers now. Okay, here are your answers if you did it correctly. Because there's 22 students in the class, there's a 1 in 22 chance of Adam's name getting pulled out. Same for Sophia in grade 3. Next question I have is Adam and Sophia, they're both really good friends. And they say, oh, wouldn't it be good if we could both be the leaders for each of our classes? So my question now is, what's the probability that Adam is the grade 2 class leader and Sophia is the grade 3 class leader? Now that green bold sentence on the right is definitely worth writing down because that will tell you how to find the answer to this question. So pause the video, write down that green sentence, make it stand out just like I have in your notes, and then see if you can use that information to tell me what's the probability of Adam being grade 2 leader and Sophia being grade 3 class leader. Do that now. If you've done it correctly, what you're working out should look like, and your answer is there is only a 1 out of 374 chance of both of them becoming the leaders of each of their respective classes. So highly unlikely, but that green sentence, that's the golden rule you need to know for today. To find the probability of two separate things happening, you just got to find the probability of each one and then times the probabilities together. And that'll work for any two independent events. We'll try one more example of this. We've got some kids that aren't attending school. So Jason, the probability of him attending school is 4 out of 7. And separate school, totally independent event. At her school, Chantal is attending school. Her probability is 3 out of 4 to attend school. So if they don't attend school, the other option is they're absent. This is a trick question. Be really careful when you read it. I've put some bold there to try and help you. You know the probability of Jason attending school. You know the probability of Chantal attending school, but my question is, what is the probability that both of them are absent from school? So think about what you know with probability. If Jason has a 4 out of 7 chance of attending school, what's his probability of him being absent? So see if you can find their probabilities, and then as the bold green instruction tells you to, see if you can find the answer of both of these independent events occurring. Go. Here is your answer. A trick question because if Jason has a 4 out of 7 chance of attending, it means the rest, which is 3 out of 7, is his chance of being absent. If Chantal's probability of attending school is 3 out of 4, her chance of being absent is whatever's left over, 1 out of 4. Times them together and there's your answer. That's the first half done. Here's the second heading I'd like you to write down, please. Dependent events. So this is a little bit similar but different in that it's where you've got two events, but whatever happens in the first event will change the probabilities of what happens next. I'd even highlight or underline the two words change the probabilities, because that's really important. It means that they are not independent. Whatever happens first changes what happens next. And this is most easily shown with a small, so don't worry too much, but a small tree diagram. Have a look at the marbles on the right-hand side of the page, the screen. Pretend that you've got these marbles in a bag and you're going to put your hand in and pick one out. I want you to start with a tree diagram telling me what the probabilities are of drawing out each coloured marble. So to decide how many branches you need one branch for each different outcome. Now you don't need 8 branches because there's 8 marbles. You need one branch for each different thing that could happen when you pull out a marble. So start by setting up your tree diagram and put the probabilities on the branches. What's the chances of you pulling out a red marble? Write that on one branch. What's the chances of you pulling out a blue marble? Write that on the other branch. Do that now. So you should have a diagram that looks like this so far. See, I've written pick one up the top because that was you picking out the first marble. So that was the first event. Now here comes the second event. You are holding that marble in your hand. So you are still holding this marble. Now your friend is going to pick a marble out of the bag, but you've still got one in your hand. So continue drawing your tree diagram for a second pick. So you're going to need a few more branches coming off the R and coming off the B to symbolize pick 2. But your probabilities will be different now. So this might help. Remember, you've got a red marble in your hand. So when you're filling out the top part of that tree diagram, the top 2 branches, that red marble I've put a big black cross through, that marble is no longer in the bag, it's in your hand. So that changes the probabilities now when your friend goes to pick out a marble. So see if you can fill in the branches, the probabilities on the top 2 branches. There's not 8 marbles in the bag anymore because you're holding one. So it's not going to be out of 8. There are not 5 red marbles in the bag anymore because you are holding one. So try and do the probabilities for those 2 top branches. Go. Here we are. We have new probabilities because, again, once you pulled out a red marble, there's only 7 in the bag now and only 4 red ones left. So there's the top branch. Have a look at the B branch though. It's still 3 because you didn't take away a blue marble, but there are only 7 marbles in the bag. See if you can do the same for the bottom 2 branches. So see here, the bottom 2 branches, it says for pick 1, you pulled out a blue marble. So I've crossed out one of the blue marbles now. Now you need to write the probabilities on those branches. Have a look what's left, just count them. Count what's left and fill in the probabilities on those bottom 2 branches. Here we are. If you've done this, your tree diagram is complete. See, I've put a heading now where I want you to fill in the sample space as well. That's the different letter combinations of everything that you could end up with. Pause it and fill in the sample space now. Should look like this. And the very final question before we finish, I would like to know what's the probability of you pulling out a red marble on pick 1 and then your friend pulling out a blue marble on pick 2. So you've got to find those probabilities, and if you remember what to do, like you've been doing earlier on in today's questions, red marble pick 1, blue marble pick 2, find the probability of both of those things happening. So find that option in your sample space and see if you can get to the answer. This is the correct answer. You've got a 50 out of 56 chance of that happening. So that's everything that you need to know for today. You can now work through the book questions.